Differentiation is just any other mathematical tool. So if you do differentiation one time, you can do it again. So what I mean is this. Let's say you take 2 times 3, okay, and the answer is 6. Could you do the same thing again? Could I take the answer and times 3 again? Of course, the answer is yes. You can do it again 2 times, 3 times, 100 times, up to you. The same thing with differentiation. Differentiation is just like plus, minus, times, or divide. It's just another mathematical tool. So what we're going to talk about today is something known as higher derivatives. The word higher derivatives sounds quite complicated, quite cheap, okay, but actually it's very simple. It just means differentiate more than once. Okay, differentiate more than one time. So if we differentiate once already, we can go ahead and differentiate a second time and a third time and so on. We need to talk about the symbols first. When we differentiate y one time, we get dy dx. So that's the first time. What happens when we differentiate the second time? We will write it like this: d2y dx square. Now you notice here that the number 2 on the top is between the d and the y. Okay, the number 2 at the bottom is after the x. So please remember that. Okay, some people are still make the mistakes of writing this dy cube, dx cube or something, for example, something like that. That's wrong, because this one shouldn't be here. It should be between here. Okay. Anyway, let me just get rid of this. We'll talk about what happens when we do it one more time. So the third time would look, well, you guessed it, instead of 2, this will be 3. dx 3. Pretty simple, right? So let's do the actual working. Imagine now this is our question, okay? Our question, the equation is given there. Y equals to 5x squared plus 1 over x, and then I want to differentiate more than once. Okay? So first, differentiate one time first. dy dx. What we get is, bring the 2 down, 10x, and then plus, now what is this? This one here, let's express it differently, okay? 5x squared plus 1 over x is actually x to the power minus 1. So if I do it this way, it's a lot easier to see. I bring the minus 1 down, I write the x, I reduce the power by 1. This power is minus 1. Okay, if I reduce it by 1, 1 less than minus 1 is minus 2. It's not 0, it's minus 2. Okay, so that's what I get. Simplify, 10x minus x to the power minus 2. Let's differentiate this again. This time is d2y dx squared. So this means I'm going to differentiate this one, differentiate one more time. Differentiate 10x, I get 10 minus, differentiate this one, x to the power minus 2, bring down. I write the x, reduce the power by 1. 1 less than minus 2 is minus 3. So the answer to this is 10 plus 2x to the power minus 3. And I can go on again and again and again. I can differentiate this 100 times if I have time. But anyway, I'm obviously not going to do that. What I just mean to show you here is you can always differentiate more than once. Take note of the symbol. Okay, the steps for differentiating are the same. It's always the same thing. Just like multiply, just like divide. Just do it again and again and again. This is useful for certain applications which we shall see later on. But for now, this is higher derivatives.